All right, cool. So first today we'll be going over yesterday's homework. We'll move on to our essential topic for today, which is object-oriented programming. So this is more conceptual based. What is object-oriented programming and how is it used? And then we'll let Brandon take over to more about how to use it in your code, basically in the form of structs and classes. And then kind of to wrap up week one before we move on to like more algorithmic and data structure based competitive programming, we're going to kind of wrap up just being able to write code from like simulating a problem or something like that. So yeah. So let's start off with our homework review from yesterday. So our first problem asks us to write a program that's going to take an integer n as input, and it's going to return the first n Fibonacci numbers. So I want you to think about this in terms of what we learned yesterday. So if we want to return the first n Fibonacci numbers, well, remember a function can only return one thing at a time, right? It can't return like multiple things. So we basically need a for loop here inside our main function that's going to process every number between 1 and n. And what we're going to do is call fib of that number, and it's going to give us the nth Fibonacci number. So what we can see here is if we want the first n Fibonacci numbers, we're going to start with 1, and we're going to go up to I is less than or equal to n in the for loop. And we're going to count fib of I for each of those I values. And that's going to basically give us the individual Fibonacci numbers one by one. So if we want to actually calculate the nth Fibonacci number, basically all we have to do is make a function up here starting on line 4. So each Fibonacci number is like basically an integer, which is what we want to return. So that's the return type that we're writing. So we write integer fib of integer n. So integer n is the parameter that we're going to take. That's the nth Fibonacci number that we want to print. So remember that the Fibonacci sequence starts off with 1, 1, and then from then on, the Fibonacci sequence is basically going to be the sum of the two previous numbers in the sequence. So since the sum of these two numbers is 2, we're going to have 2 here. Then if we're going to sum these two numbers, it's going to give us 3. Sum these two numbers, it's going to give us 5, etc., 8, 13. So the idea here is we notice that there's a base case. If it's either the first or second Fibonacci number, then the answer will be 1. Otherwise, we want to be able to sum the two previous numbers to get the new Fibonacci number. So that's basically what this code is doing here. So if n is less than or equal to 2, we want to return 1 because that's basically the answer that we know for sure. But if we don't know what the next Fibonacci is, then we have to call the function again with the number before it and the number 2 away from it. So let's just run through the code for, let's say I want to calculate the fourth Fibonacci number. So what's going to happen here is I'm going to put 4 inside the parameter because that's what n is equal to. So we see we're going to go through the if statement. If n is less than or equal to 2, so is 4 less than or equal to 2? That's not true, right? So we're going to turn fib of 3. Let me get here on my mouse. We're going to return a fib of 4 minus 1, right? Because n is 4 right now. So we're going to return a fib of 3 plus fib of n minus 2, which is 4 minus 2, or just fib of 2. So basically from having to go from the problem fib of 4, which is what we want to find, we're able to simplify this to fib of 3 plus fib of 2. And again, if we want to simplify this again, fib of 3 is going to get plugged in into the function. So let me erase this quick. So now n is equal to 3. Is 3 less than or equal to 2? No, it's not. So we're going to return this again. So fib of 3 is going to basically equal to fib of 3 minus 1, which is 2, plus fib of n minus 2, which is 3 minus 2. So n minus 2 here, 3 minus 2 will be 1. So basically, that's what those values are. And each of these individual pieces are going to run. And basically, it's going to go through this if statement again. And now we know that since this is the value of n that we're plugging into the function, which is 2, and 2 is less than or equal to 2 now, then we'll return 1. And same thing for here. Fib of 1 will go through this if statement and return 1. So these two values combined will be 2. So that means that fib of 3 is equal to 2, right? And that makes sense because if we're looking at the output here, for example, these are the first two Fibonacci numbers, and the third Fibonacci number, which is fib of 3, is equal to 2. So that's what we just calculated over here. And next, we're going to do something similar for fib of 2. We already calculated, I already show how it goes to the if statement here, and it returns 1 by itself. So it's going to get the plus 1 over here. So fib of 3 plus fib of 2 is equal to 2 plus 1, which is equal to 3. So that means the whole entire value of fib of 4 is equal to 3. So that makes sense also, as you can see in the output. So this is fib of 4, which is 3, which is basically what I just mentioned. So essentially what's happening is it's taking the last two values until it finds that the nth Fibonacci number is less than 2, and it's going to basically add up all the numbers to get the nth Fibonacci number. So that's the idea behind this problem. And here is our next problem where we're asked to write a program that takes a string as input and returns the reverse version of that string. So I hinted at using recursion for this just for practice, but there is an easier way of just using a for loop and going through like the length of the string and going backwards. But for the sake of learning recursion, be basically asked to print the string in reverse, which is a little bit more challenging, but it lets you think about like the logic behind it. So that's why we made this problem. So in the main function, there's not too much happening here. We're just going to create a string and read it in from input. And we're just going to call the function to reverse it with the parameter of the string. So we want to reverse this string. So let's look at some base cases. So if a string has nothing in it, then there's nothing to reverse anymore. So all we have to do is just return. We're done at this point. Otherwise, what I'm going to do is I'm going to say, let's say our string is like hello, for example. So if I want to print this string in reverse, I have to start from here. I don't want to print this right away, right? I don't want to print H right away. I don't want to print E right away, L right away, L right away. I want to print O first. So what I'm going to do is over here, I'm going to call the function before I print out the character that we're currently at, because I want to move through this entire string and get to the last character so I can print it out before I come back here and print the rest of this stuff out. So what's happening here is we already covered this if statement. So we're going to set a temporary string with nothing in it. So I just put quotes over here. So this means an empty string. There's no characters inside it. So what I want to do is I want to separate the first character from the rest of the characters inside the string. So that's why I'm going to start at index 1 and go through the length of the string here using a for loop. And I'm going to say character C is equal to the character that we're currently at. So similar to kind of like arrays and vectors, you can use indexing to kind of get the character that you want exactly. So at index I, so we're going to start off at E. And we're going to push back the character starting from E, and we're going to go through the rest of the string. So this temp variable in the end after this for loop is going to store ELLO. And notice over here, I don't want to print H yet because I want to print the string in reverse, right? So my string is hello. I want to be printing OLLEH. That's the reverse string. So I don't want to print the H first. I want to delay it until the end. So that's why I'm putting the count after the function call for the recursion part. So then I'm going to call reverse string on temp, and it's going to run the same exact process on the string LO, because that's what happened in temp. So temp is LO, which we got from the for loop, and I'm going to run the same function on LO. And essentially what's happening each time this function gets called, the first character of the string is getting removed. So I'm going to separate it like this. It's going to become LLO. Then it's going to separate like this again. It's going to become LO. And lastly, it's going to get to O. And then here already here, I'll get to O by itself. And then I'll get the string again. And then it's going to be an empty string. The length of the string will be 0 after this. So basically what's happening is I've got an empty string I'm going to return, and I'm going to print out the first character of the last string, which is O. So it's going to print out O first. Then it's going to come back here to LO. And after this square part that I basically circled for the O, that was the string that we were calling the function again. The reverse temp string temp value was O, and then we're going to print that out. So we did so. And then we're going to print out the next value, which is L. And then I'll return again. And then I'll basically just print out the rest of the characters. So L, 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 E, H. So basically what's happening is we're delaying printing the value of the first of the place we are at until we reach the last character. Once we reach the last character, we print the last character, then it's going to come back here. It's going to print this character because it's after calling the function. And it's going to do the same thing with other letters until we get a reverse version of the string.
Also, like, I want to say, wait, bring that back.
Yeah, sure.
Like, what you can see here is like similar to the data structure you mentioned last time. Like, this is similar to a stack, which is like last in, first out. So basically, first he called hello, then LO, then low, then just like normal O, and then O. So basically, since O is the last one in before you call the base case, it's now going to be the first one you print out. So now that's why you're getting O. And then second, which is the second last of the calls, you get L. And as you can see, the ones that you put in last are going to be the first ones that the first ones that terminate, and the first ones that you execute on. So that's essentially how the stack is used to represent this.
All right, so let's go over one last simpler example from the homework yesterday. So essentially what this number problem was it was asking, I'll give you n integers, like I'll have you read in a number n, and then I'm going to give you n total integers. And I want you to tell me how many distinct or different types of numbers there are in that input. So first things first, we're going to read in n and basically just see it in. And notice that we are trying to find how many different numbers there are. We don't care how many there are in total. We just care about how many different ones there are. So to solve this, we can use a set. So a set, basically, remember from yesterday's lecture, is going to be kind of like a vector in that it stores numbers, or like any, in this case, numbers, but it can store any type of data type. But in this case, we want to store numbers because it's from the input, right? So the reason why we're using a set is because it doesn't have any duplicates. Whereas if you have a vector, then each number that gets inserted can have a duplicate. Like I can have a 2, a 3, a 2, another 2, a 1. Well, I can store infinitely amount of numbers, but there will be duplicates inside it. But if I use a set, then I don't have to worry about duplicates, because let's say I have like a set that's 1, 2, 3, 4. For example, a set contains these numbers. Well, if I insert another number, if I insert a 3 into this set, well, nothing will happen because 3 is already in here. Sets don't have any duplicates. So what I'm doing is I'm reasoning that, okay, so since I don't want any duplicates, I want to find how many different numbers there are, then I should use a set data structure to basically store the numbers that I want to put there. So then here it's pretty standard. I'm going to use a for loop to read in the n numbers that the input gives me. I'm going to kind of just define it and read it in as input. And then I'm just going to insert it into the set. And at this point, we basically got a set of all the numbers that the input gave us. And all we have to do is print out the size of the set because we know for sure there are no duplicates. So that's the idea behind that problem. Okay, so with that being said, let's move on to today's topic, which is based on object-oriented programming. So object-oriented programming, I want you guys to think about as the concept of objects and classes. So I'll explain more what that means later on. But basically, so far we've been showing like all these USACO problems, CSES, and like code forces, all those competitive programming problems. Those are more logic-based and being able to actually solve them. But classes is basically going to, an object-oriented programming in general, is basically going to let you have your own structure to build these objects from scratch. So far you guys have been going over like vectors, sets, maps, all these data structures and data types. And overall, these are all objects. They're created from classes. And just as how these classes have been created for your use in C++, classes can let you create your own user-defined data types. And just like how we have like an integer, and we can have like a double, a float, a string, a character, we can also create our own data types using classes. So that's where these are useful. And using these classes, again, since just as we can create an array in programming, we can create a vector in programming in C++, for example, we can also create specific instances of data types. We can create our own versions of data types in our code. So on the left, a picture here, you could see that we're creating kind of like a student object over here. And a student, for example, like every student has a name and every student might have like a roll number or ID number or grade level, something like that. So this is like kind of like a structure of a student that's represented by the class. And here on the right, we can see some examples of objects that we've given, that we created. So we have like an Atom object here, with their name inserted at the top, and we can have like their roll number to be 12, and same thing with Kesha. We have a name and we have a roll number. So these are basically examples of the object that we originally created. So let's take a look at some classes and structs, which are both examples of object in programming. So the difference between classes and structs is not too big, but you could kind of use either one. They're almost interchangeable, but not completely. So let's look at the left. We're creating a class dog. And all you have to do that is type class and then type the name of the class. By convention, you want to type the name of the class to be capitalized. So that's why I'm putting capital D over here. So that's more clear that it's a class. Just by convention, you don't have to, but it's recommended that you do so people can kind of understand your code if they're reading it for the first time. And if we're thinking about a dog, we might have an age for the dog, a breed for a dog, a weight for a dog. And you kind of have to think about what data types are going to be. So age might be an integer. So like a dog might be 5, 6 years old. A string for the breed. Maybe the dog is like a golden retriever. You want to kind of store that in the string data type. And lastly, the weight can be represented by a double because he might be like 50.26 pounds, for example. And similarly, we have structs over here on the right. So let's say I want to create like a point, the concept of a point object inside the XY plane, for example, the coordinate system. Well, I can have an X coordinate, which is an integer, or I could use a double for that. Actually, both work. And basically just on your use case, but I can have an X coordinate and a Y coordinate, which are both represented by integers. And the difference you might ask about classes and structs is like, what's the difference, right? So by default, if you don't change this, the variables and the methods that like whatever the class does, basically, it's going to be private, which means it's not accessible outside the class. So basically what I'm saying is I can't access age and the breed and the weight outside these curly braces because the members of basically the class are private. So they're not accessible outside the struct or the class. And the difference between that and the point is that for the point, you can actually access X and Y outside of the class. So this might be useful when you're thinking about like who should be able to access like or change your code for a specific objects inside your program. So next I'll be going over, no, I'll let Brandon go over more in depth about classes and structs.
Yeah, okay, I'll be going a little more in depth about those. So we did mention that structs are by default public. So we're gonna put like our variables about the dog into a struct, and then we're also gonna put a function here, count, bark, and line. So we can also call functions from classes inside the main. So let's say like the code on the right is in the main. We're gonna instantiate like an instance of our dog class and name it Fred. So now we have a dog Fred, and we want to assign some values to it. So let's say Fred.age equals 5, and then Fred.breed equals golden retriever. That's fine. And the reason why we're allowed to do these assignments is because this is a public, so from the main we're allowed to access it. So Fred.weight equals 40.5. Now if we see out Fred.age, we get 5. And then if we do Fred.bark, that also works because it's inside the public dog. So we're going to do Fred.bark, and then it's going to call the function, and it's going to do what it does, which is see out bark, and it's going to print bark. So yeah, you can basically just create instances of your structs or your classes, just like you would with a normal variable. You can create instances of them. But now let's go into classes, and you might be thinking, since classes are private, like there's no use of them, right? Like you can't even like use them outside. Like what's the point? But we can use access modifiers. Like these allow us to like change whether which specific ones we want to use outside the class and which ones we don't. So in terms of programming in general, it's recommended that your variables be private because you don't want people outside messing with these variables, but you want to give them a set of like functions that they're allowed to like modify these with. Like you want to give them a set of functions that allow them to access the values here, but you don't want to give them direct access to them. So that's why we put these private, but then we set all these getters and setters, which are like, they allow you to get the value and set the value of them. We made all these public, and additionally, these are called constructors right here. So if I create an enemy without any given parameters, it would just assign them the default value of this. But if I wanted to give them some sort of parameters, I would just define it like this. I would define it with these three parameters and would assign them here. So let's see what the code is in the main. So I create an enemy skeleton, and then I decided to use this constructor right here. So I would assign it health 100, attack strength 50, and position 0, because our private variable is going to be assigned to these. And by the way, anything that's inside this function will be allowed to access these private variables. Private variables are only not allowed to be used outside the class. So that's why health equals H, like that's why this works. It's because it's in the same class, so it's allowed to access it. And because this is outside the class, like this definition right here, if the only way I can change these variables is by using this constructor or by calling these functions if I want later on. So now I'm going to call .move, which is valid because that's a public function. So now it's going to update the position of this plus equals 50. So now instead of 0, my position is 50. So we're going to keep that in mind. And this is for the skeleton instance. For the specific skeleton instance, we have 150-50 as our things. And then we're going to get AS, which is going to return attack strength. But actually, this doesn't really do anything, though. It would just return an int, but that really doesn't do anything, because if you want to print it out, if we did like C out, get AS, then it would print out 50. So yeah, you can keep that in mind. And then now it looks like we're defining another class, hero, which has attack damage and return attack damage. So yeah, so basically like this is just called right here, this is just called a getter. Like, so you could just return any like private variables, like since this is private, and if we made this public, then that would be effective. And then now we're creating a Superman of attack damage 100. But like, since this is private, we wouldn't even be allowed to access that. But let's say I put like a public here, then I would be allowed to use .attack if I wanted to print it. But if I want to do a set, then I have to do a int. Then I would have to do void because I want to set the variable. I would do void set attack, and then I would take in the integer I want to put in, and then I would just say attack damage equals n. And then what I would do in the main, if I want to set it equal to 100, I would just do this right here, Superman dot set a 100, and that would allow us to access the value and modify it. Since as you keep in mind, class hero is by default private, so all of these things inside are private. So I would not be allowed to just call it directly like this. I would need to access it with a helper method that's public, that's defined by public. Okay, and then now we have we're comparing Superman dot attack So let's assume that this is like public right here as I put the tag here. So we're going to compare that to skeleton.getAttack. And we know that we set Superman dot attack the attack damage of Superman to 100 versus 50 for skeleton as we listed right here. It's currently 50. So 100 is indeed greater than 50. So it's going to return a true Boolean, and we're going to go inside and we're going to print out that Superman wins. So yeah. Okay, now that we're done with that concept, if anyone has any questions, leave it in the chat and we'll answer it. But now I'm going to go over some review that you're going to need to tackle on next week's problems. These are mainly like simulation problems, like the problem tells you, okay, so here's the situation, and you just want to code it up and like just follow the direct process of basically what they tell you to do. But it's not as easy as it sounds. So let's just go into like one example. And okay, so it's 10:30. I'll give you guys like 3 minutes. 10:33, I'll probably start explaining. But if any of you guys have any ideas of any data structures, any algorithms, or like any sort of like for loops or what your thought process is, just leave it in chat. And we're gonna be yeah, that'll be how it is. You guys should try to like solve it yourself because that'll help you out a lot more when you're trying to like train for these competitions. Does anyone have any ideas so far? Like just any like data type they'd like to use? Any for loops or like any of the concepts we've taught so far? Anyone want to say anything? Chat or yeah. Okay. I will just be going over it then. So if you guys saw like my latest announcements, you can see that there's actually like you can represent these with pairs, which are basically just a collection of like two data types, and you can like store it as like one like this. So that's one way to look at it. You could definitely store it as a vector of pairs at the intervals. So in terms of our structure, we could definitely utilize this. But let me go into like a Jamboard. Like let me just write out like how to actually uh, define a pair, and then I would just say, okay, this is the intervals that we want to take in. So we can represent our times like this. We can read it into here. I actually did something a little different though, because I wanted to teach today's lesson, but that's one valid way to do it. But before I get ahead of myself, let me explain the problem. So there's n cows hired as lifeguards, and the pool's open from 0 to 1,000. And given that the time, so basically each shift can decide two integers, and then they start from one time, and it gives you the ending time. And then if it's from 4 to 7, then it's saying that that covers like 3 units of time, for example. Okay, so then we would just do like b minus a, and that would give us like the total amount of time of that interval. But John hired one more lifeguard than he has the funds to support. So what's the maximum amount of time that can be covered by the shifts of the remaining lifeguards? So there's many ways to do this, but the most intuitive way, and in bronze, you're always gonna be looking for like the most common sense, like what you think of when you want to solve this problem, like what makes sense. If I want to test the maximum amount, I probably want to be testing each scenario and comparing them to each other and seeing which is the most effective in terms of giving the total amount of time. And so basically my logic for this is I would just remove a cow, like a different cow every time. And then for each iteration, I'll just test how many hours we still have remaining when that cow is gone. And then I'll compare it to each one. And then whichever iteration has the most time after removing one cow, that's the one that I want to keep because there's the least impact from firing that cow. So I can go over like drawing of it if that makes it more clear, but yeah. So I'll just copy this from right here and then I'll just draw something real quick on a GM board. Okay. So we have the timeline right here. Wait, let me just drag this up here. Okay. We have the timeline from 1 through 1000, but like for the sake of this problem, we don't actually need to draw. For the sample input, it's unnecessary to draw 1000. So I'll just go like this. And then we see that this time slot is taken up by the first, and then this time slot is taken up by the second person, and then this time slot is taken by the third. And it's asking us if we remove one cow, then we want to have the maximum amount of hours remaining. So the way we can do this just by simple simulation is, okay, let's remove this. How much time is still covered? Okay, well, let's say that's 3. Okay, remove this. How much time is still left? Okay, let's say that's like 6 or whatever. So that's greater than our current running maximum. So we'll remove and we'll replace it. Okay, now let's remove this. How much time? Okay, oh, it looks like we only have 5 units of time covered. That's not greater. So now our answer is like 6, right? So that's basically what our logic is, and now we just have to code it up. Okay, so as I mentioned here, the maximum of all the trials, and you just compare each trial when a cow is removed. As I said, you can definitely use pairs, but I decided to go with a custom data type that we implemented as struct from today's lesson, which stores the beginning and end time. You could also do this with a pair that stores 2 ints, but I decided to use structs here just to show how they work. And I made it of size n. And this basically just takes in all the possible intervals. I just want to keep those. I want to store those. And then I'm going to create a timeline from like 0 to 1000 because that's the maximum. And then the current running maximum that I mentioned before is max time equals 0. So at the beginning of each iteration, I want to make sure that the whole timeline is false. And then here, as it mentions here, I keep on changing the cow that I do not want to include in my current iteration. So in the first run, I'm not going to include the first cow, and I'm going to test what that effect is and how many hours I'll have remaining. So I'll go through every single cow except the one that I decided not to include using this statement right here. And then I'll basically just mark the timeline with true with all the intervals that these cow covered up. And then based on the number of true booleans, I'll update my cur time to like to that symbolizes like how much time is covered up by the remaining cows. And if this is greater than the current running maximum, I'll replace it. So the maximum function returns the greatest of two functions, two inputs. And basically, if my current one is greater than the current maximum, then it'll replace it. But if it's not, then it'll just remain max time. And then I'll just do this for every single cow. And in the end, I'll eventually get the maximum of every single iteration. And then I'll just print it out. And also just another thing to keep in mind, like if you're not using bits over here for max, you would probably want to use hashtag include algorithm to get the max function. So yeah, but I always use bits, so it's basically just your preference, but yeah, keep that in mind. If there's any questions for this problem, leave it in chat, but I'm gonna go on to the next one, and yeah. Okay, so here's another useful problem, and I'll give you guys until 10:43 again, something like that, and we'll see how everyone does. And don't feel free to just leave your opinion in chat, like what you guys are thinking, your logic, and I'll help you out in the future. Okay, we're just about reaching 10:43, so if no one has any opinion on this problem, I'll just go over it. Okay, so let's see what they have here. I'm assuming you guys read the problem, but I'll go over it just in case. So there's K different practice sessions, and there's N cows who are ranked based on their performance. So there's K different sessions, which in this case is 3, and then there's 4 different cows, and in this example, being ranked. Okay, and we want to see how many consistent pairs there are, and a pair is consistent if one cow did better than the other one in every practice session. So basically, if like 4 is ahead of 1 the first one, we want it to be ahead of 1 in every single session. Okay, so we know that 4, 1's a consistent pair, and it says it right here. Let's see about 2, 4. 4 is consistently ahead of 2, so that makes sense. 3, 4. 4 is consistently ahead of 3, makes sense. 1's consistently ahead of 3, we see here, so that makes sense. Okay, so we know what a consistent pair is. So basically, it looks like that we just have to keep track of every single row. If the relationship is the same every time, then we can add it to our count of consistent pairs. So all we have to do is just like think about what data structure we want to store this in, and just looking at this format, I think like a 2D array is looking good because we have like a row of integers, which is like an array of integers, and then we have an array that stores this array of integers. That like so it looks like that would represent this very nicely. And then if you want to keep it consistent, I think we would need to like create a for loop, and then we'd have to go through it. And if the current iteration is equal to the previous one, the relationship, then it's fine. And we just have to make sure that it's like that for every single time. And that's essentially all we need to do to solve this problem. So if we iterate through the whole thing, checking for one relationship, and all of them are the same, then we can bump up the consistent pair count. And then I'm going to show this in code. So as I said here, the key idea of this problem is store it into a data structure that makes sense, which is a 2D array, and then keep track of the first row's relative position. So in this case, I just kept track of the first row, and then I just iterate through the rest to make sure it's the same as the first. There's many ways you could do this, but this is just the way that I wrote it in this scenario. And if the following codes do not have the same relative position relative to each other, then I'm going to say that's invalid, and I'm not going to bump up the count. Otherwise, I will. So over here, you can see we're reading our input into a 2D array. On the top is just file IO. I mean, the top one just makes your file IO faster. It's not necessary to the functionality, but in competitive programming, that might help a little bit. And then I'm gonna read in the file using this this format, and then I'm gonna allow myself to read it out to a file named gymnastics.out using this line right here. Okay, so now I'm gonna read in K the rows of this column, and then also the N, which is the columns of this table. And I'm gonna put it into data, which stores all the different placings and the different sessions that are there. And then I'm going to want to have all the distinct pairs here, right? So let's say it's 1 through 4 as our set. In order to be distinct, I would have 1 here, which is what I does. And then J would iterate through the rest. So 2 through 4. So 1, 2, 1, 3, 1, 4. And I'm gonna move I here. And then to get the rest, I would go 3 and 4. So 2, 3, 2, 4 are another distinct pair. And finally, I would end at n-1. And then 3, and then J would get the rest of the distinct pairs, but in this case, it's only 3, 4. So using this loop right here, I'm getting every single distinct pair that's present inside our specific row that we're looking for. Okay, so let's say I'm going through the first iteration and I want to compare 1 and 2's positions. Okay, so now I'm going to iterate through the specific column, the first column, and I'm going to check their relative positions. So let's say the position of 1 in this array is 4, and then the position of 2 is the first element in the array. Let's say j pause is 0. So we know that j pause should be ahead of I pause in every single rest of the rows, or else this pair is not consistent. So now we're iterating through the rest. See, notice how I start at 1. So we're going to iterate through the rest of the rows. And we're just going to go through, and then we're going to check the relationship and keep note of this temporary position of each. And let's say the position here is j temp is 2 and then I temp is 3. So like so that means that j temp is ahead of I temp in this scenario. And then we're basically comparing this. So I temp is less than j temp. That is false. So this can be false. And I pause less than j pause. That's also false. And these are equal. So that returns true. And then if these are not equal, then we're going to go in here and mark it as inconsistent. However, these are equal, so we're never going to go into this if statement for this specific iteration. And then we're going to go here and then mark our, and then we know this is a consistent pair, so we're going to bump up our answer by 1. So basically, one thing you need to realize is what this specific if statement is doing. It's comparing the relative position of each. So if the positions in both scenarios are the same, then it's gonna keep note of that. So if itemp is in front of jtemp and itemp is also and ipause is also in front of jpause, then we'll know that it's consistent. And also if ipause is behind jpause, and then if itemp is behind jtemp, that's also consistent. So we're basically just saying if the relationship is not the same between these two variables, then we're going to mark it as consistent. Otherwise, we're going to leave it as true and we're going to bump up our answer. So basically using this and going through all the rows, we can keep track of all the consistent pairs and we can update our answer counts, and then we can just print out the answer at the end. So that's it for that problem. If you have any questions, leave them in chat, please, and we'll be sure to go over it. But finally, now we're going to go on to the last problem of the day. It's named daisy chains. So please take a good look at this, and we'll be back at 10:52 to talk about this. Okay, so it's 10:52, and I hope you guys thought about this problem. And if you have any thoughts, just leave them in chat. But now I will go over it. So basically, it looks like we have n flowers lined up in a row. Okay, one, and then this row can range from 1 to 100 flowers. Okay, and then each flower has 1,000 petals. Okay, let's keep that in mind. And then there's a photographer who takes several photos of these flowers. And Bessie looks at these photos and notices that some of these photos have an average flower, a flower that has p petals, where the average is exactly equal to the average. Okay, so there's a flower in the photo that has the same amount of petals as the average count in the photo. So how many of her photos have an average flower in it? Okay, so we need to think about what a photo actually is. So it seems like for every pair of flowers I through J, she takes a photo of all the flowers from I through J. So a valid flower would be a valid photo would be this. One is just a photo. I through J, so if I is 1 and then J is 1, that's also a photo. So she can take individual photos and that would be completely valid. But she could also define a photo from 0 to 1. So 1, 1, 1, 2, and then 2, 3. And then she could also take a photo 1, 1, 2, 1, 1, 2, 3. And then she could define her photo from 0 through 3. So that would just be the whole thing. Okay. So what we have to do in this problem is we'd have to add up all the numbers inside this photo, and then we want to divide it by the count of the photos in the count of the flowers in that photo. And that would give us the average flower petals in that photo. And then we want to compare this average that we've received to every single element of that specific photo and see if there's any match. And if there's an average that equals one of the flowers in this photo, then we know that this is a valid photo to be added to our answer. So as you can see here, every single individual flower is equal to the average because 1 divided by 1 is 1, 1 divided by 1 is 2, 1, 2 divided by 1 is 2, and 3 divided by 1 is 3. An average is equal to sum over like number of elements. So basically, if the number of elements is literally just like 1, and our sum is just equal to itself, then basically like num is just going to be equal to num over 1, and then it's just going to be equal to itself. So every single photo that just takes a picture of one flower is going to be valid. So by default, we know that the array size is always going to be part of the answer. But then we want to keep note of any other things. So let's look at this photo. So the sum here is 1 plus 1 equals 2 divided by the number of elements, which is 2 equals 1. Let's see if there's any flowers in this photo that's equal to 1. And right out the gate, we see that there's a 1. So this is a valid photo because there is indeed a flower in this photo that's equal to the average. If we looked at here, then that would no longer be the case because if we look at the second flower and the third flower, we add them up. So 1 plus 2 equals 3, 3 divided by 2 equals 1.5. There's no flower that's equal to the average count here, so that doesn't count. But let's look at here. They're saying 2, 4. Okay, so I see that's 1 index. I think I said it was 0 index before, so that's my bad. But if we're starting from 2 and then we're looking at 4, let's take the sum. 1 plus 2 plus 3 equals 6 and divided by 3 equals 2. So we know that the average flower count in this specific photo is 2. Let's look through it to see if there's a flower that matches this average. 1's not equal to 2. Okay. 2 is indeed equal to 2. So now we know that there is an average flower inside this photo, so we'll add that to our count. So we know 1, 1 was a valid photo, and 1, 2, 3 is also a valid photo. And we know that all the individual photos count. So by this logic, we have 4 plus 1 plus 1, and we know that there's 6 total valid photos in this specific problem, in this specific input. Okay, so let's expand this logic to our actual the actual overall problem for all inputs. So the key idea is to generate all possible combinations of photos. And using these different combinations, we want to calculate the average, and then we want to look through the photo and see if there's a flower that's equal to this average. And if that's true, then we increment our total answer, and we just end up printing it at the end, like we have been for this entire scenario. So all these problems so far. So basically, just read in the total number of flowers. And then I decided to store the flowers in a double. You could actually just store it in an int, but I just decided to go with a double because I think that would help me avoid some division errors later on. So that's why I used doubles. And then I'm going to read in the inputs into the different indexes of this vector. And you can see here I defined the size initially. If I didn't have this here, it would error out because there's no space that I allocated to store anything there. But I made it have n empty spaces, and therefore I'm allowed to read in n inputs. So I'm just putting in the different inputs that I listed. So basically, I'm just storing this into array, the 0th index. I'm putting this into the 1st index, this one to the 2nd, this one to the 3rd. So I'm just putting these elements into my flowers vector. Okay, so now I want to have an answer that stores the total count. And basically here, I'm just iterating my picture range. So, at the beginning, I only want to take note of individual photos. but later on I want to get a range of 2, or I want to take pictures with a range of 3. So on the outside, I'm going to be incrementing that count. And then here, I want to go through every single possible photo that has that range. So what I mean by this, so like I want to, if I is currently 2, for example, I want to be able to take a note of this photo, and this photo. I want to make sure that I'm looking at every single one. And let's say that I is 2, and in this case, n is obviously 4. So it would go from J, the starting point would be here. The starting point would then be incremented to 1, and then less or equal to n minus 1. So 4 minus 2 is 2. So it would stop at 2, but it would go here, and then 3, it would not go anymore. So basically, I'm basically just iterating the starting point of every single one of the photos I'll be taking with this specific range, which is I, and in this case, it's 2, for this example that I just put up. Okay, so now that I have the starting position J, I'm going to go from J to the range to the current index plus the range, which is I. I iterates the range. And then I'm going to add every single flower in this range. And then I'm going to divide it, and then that'll give me the average. Okay, so now I have the average, but I want to compare it to every single flower in this photo to make sure that there is a flower in here that's equal to our average. And only in that case, I'll increment the answer. So basically, all I'm doing is iterating over the same range I did here, which is the starting point and then the range, which is represented by I. So I'm going to make sure that if there's any flower in here that's equal to the average that we currently have stored, then then this is a valid photo. So I'm going to increment our answer. But we want to break because we don't want to keep on iterating, because if there's like multiple flowers in this specific photo that's equal to the average, we don't want to bump up our answer more than just once. Once we figured out that there's at least one, we break, because now we figured out this is valid. Each photo can only increment your count by 1. So that's why that we have to break here to make sure that we only at most increase our answer at 1 for each individual photo. So basically all we're doing is taking note of every single possible combination of ranges and positions. And then for this specific range and position, we're getting the average and comparing it to all the flowers in that photo. And then we're determining if that specific photo is valid or not, and we're incrementing our counts. And in the end, we just print our answer, and then the grader gets it, and then that's how it is. So it determines that our answer is correct. Okay, so that's basically it for all the simulation problems that will help you get a grasp of CP and help you guys understand the algorithms we'll be going over next week. So
Yeah,
if
so thank you everyone for coming. So basically this is going to conclude our kind of like syntactual part of our bootcamp for C++. So you guys at this point are able to kind of write code for any type of program that you guys want to create, basically. At this point, like guys might know Python or Java, something like that. You guys can write code just as well in C++. Basically, what we're going to start next week is going to be based on more algorithms and data structures that you guys have to know for competitive programming, and that they will be essential for helping you guys solve more complicated problems that are more about like kind of being able to see the problem and basically let it run faster than just simulating it. So yeah. Thank you everyone for coming. This concludes our meeting for today, and we'll see you all next week. There's no homework for today because it's the weekend.